Hi guys, this is Rohan and I welcome back to my channel. In this video, I'll be discussing about 15 different things you can actually do with tMap. And of course, tMap is one of the important component in Talend, which is being used in almost all the jobs on a day-to-day, project. So I thought I'll make a list of all such, features and present it in this video. Okay, so let's get started. The first one is joining tables or files. If you have two different data set and you wanted to join, you can do such joins within tMap, whether it is a database or a set of files. You can perform the joining operations, and you can also capture join rejects, especially when you do inner join with two different data set. There's a possibility that some of the records may not fall or may not match. So you can capture such rejects using tMap. And the third thing you can do is lookups, whether it is a table or files, or if it's a combination of both, you can perform lookup to perform some matches. Okay. And in lookup, there are two different types. You can do a static lookup or a dynamic lookup. It is also called as cached or non-cached. You can pretty much do using tMap. So moving on, you can do a filtering of rows and also columns. Let's say you have a condition, based on that condition you want to filter, you can very well use tmap. And also columns, so let's say if you have 100 columns coming from source and you need only 10, you can actually filter whatever is required. And moving on, expressions. You can write your own custom expressions, like case statements or decode statements based on certain condition. Change the value of that. So you can write such expressions and also perform transformations. So let's say you have certain date format that you wanted to change, or you want to do some related to string or any integer or decimals. You can do that transformations within tmap. And next one, you can have multiple outputs. Even though you have one single input, you can use that single input to create multiple outputs. Based on certain condition, you can create multiple outputs and have your target loaded. So moving on, if you have certain functions or calculations or some sort of processing which you have written in Java routines, you can pretty much embed that routines in Talend and call those Java routines using tmap. You can do that as well. And similarly, you can even invoke system or user defined routines or functions. So there are set of system defined and also set of user defined. You can write your own and then call them using tmap. And also you can use tmap for generating sequence numbers. So if you are loading dimension tables, you can generate a sequence based on some built-in features. So moving on, you have a capability to add your custom columns such as insert date or update date or any other column. And you can have your own variables created and perform any expressions or calculations, right? You can do that as well, or you can concatenate or any such things. You can do it using variables. And there's the auto mapping features. Let's say there are like 100 different columns from source to target, and you don't have to map them manually. So tmap provides a feature using which you can auto map the column from source to target. And also you can perform some simple calculations, such as calculating bonus based on basic salary, or based on some percentages. You can perform a set of calculations. And if you have a string, you can perform various string operations such as upper, lower, or substring, or any type of string handling or operations. You can do it using tmap. And if you have like different output groups, you can pretty much data into different groups. Let's say you have three different outputs, and for each of them you can define different filter conditions. So let's say if your department id is less than 10, follow this particular route. If it is less than 50 or greater than 10, you can use it as second output. Or if a, let's say if the salary is more than 10K, you can use the following, the third output. So you can have different filter conditions for different outputs. And also you can catch all the output rejects. So let's say there is some data constraints or some constraints like not null or exceeding certain length of string. So such bad data you can actually capture using output rejects. So this feature is also provided by Talend tMap, right? So these are some of the 15 features that I was about to tell you. And we will do the hands-on in just a minute. So prior to that, I just wanted to introduce my new website, talentpro.com. So this is where I'll be uploading all the free content, resources, and some of the downloadable links. For example, sample data files for your practice purposes, or anything related to Talent and useful for the developers. I'll be posting all the content. So talentpro.com. And I've got my mobile applications both on Google Play Store and App Store. You can very well go ahead and download my app. So that's where I'll be adding more free resources as well. And there are some free content, study materials. Some are covered in my website, and some are exclusively within the app because of some privacy and other reasons. I have kept it inside my app. Let's get started with the hands-on session. I have a job created for this demonstration purpose today. All right, so let's pull in a couple of tables to demonstrate how do we read and add expressions into our flow. All right, so for that, I'll be using MySQL table. So I have created a metadata already, and these are the tables available. So let me pull one of the table here, the users, and I'll be using it as a DB input component. All right, so we have all our connections and tables and the column list and everything is populated automatically. So using the metadata is a best practice so that you can reuse all your table definitions. All right, so next thing I'll pull up is a tMap component from the palette. All right, so I have pulled the tMap component here. So let's go ahead and do a row main. Okay, so now the input component is now connected to tMap. Let's get into the tMap and let's see. Okay, all right. So from the user table, I have only three columns: ID, first name, and last name. So for this explanation, I will be creating one output for users. So the output is now created. All we have to do is pick up these columns and drag it to the target. All right, that's all. Now that we have copied all our input columns to the target, link here, all we have to do is just right click on the tMap. Now you'll be able to see the users. Click on the job design area and then let's print it on the console using the tlogRow component. So once this is tested, you can have your own file output, or you can even have a database or whatever operation you want to perform, you can have it. So for this demo, let's go ahead and run this flow. All right, the job is now running. All right, it's completed. Let me expand this run tab. All right, so as you can see, that users table has 1,000 records. So all the records have been read from the source and directly written into the target. Now, we are not doing anything as of yet. I just wanted to show you this is how it shows up. And let's try to add some expression here, and then we'll show you how it works.
Now for this first name column, I want to apply some expression here. So for that, so when you click on these three dots here, it will take you to the expression builder. And after that, you will see a lot of categories here, like data operations and mathematical, numerical, relational, string, and date. There are several options here. When you do this hands-on, you should be checking all these available functions in each of these categories. So for now, what I'll do is I will go to string handling and I will use upcase for this transformation. All right, so as you can see, we have to do is the string handling dot upcase and then the input column name. So this is one way of doing it. Otherwise, you can even just type in string um, partial word, and then you'll be able to see all the suggestions for this particular function. All I did is I typed the string h and then pressed the control and space. It'll show all the possible functions within this string handling. You can do this as well. Like you can just double click, and inside it you can take out the hard-coded value and pull your whatever the column you wanted to perform this function. That's all. So for now, I'll keep just the first name. And there's a way you can actually test it. If you have any syntax issue or anything, you can test it here. It'll show up any issues related to this, function. Let's go ahead and click OK. Click OK, and let's see. So this time I want to see all this first name column to be printed on uppercase. And I'll do one more setting here on the tlog row. I will enable stable format. All right, so now let's run it. Okay, now as you can see in the run tab, all the first name is now in uppercase. Now I'll include a date, basically to capture the record insert time. For that, let's go to the variable section and we'll go to the talent date. And if you see, there are like a lot of functions available. For this demonstration, I'll just use get current date, and this always returns the date format. All right, sorry. So all we have to do is get current date, double click on it so that it is on the expression window, then click OK, and now it is of a date data type. We'll change it to date, and we'll give some name here, and we can drop this to the output component. So this will be generating the current date, and then we are passing it to the one more column on the target side. So let's rename this column. All right, so it's of date, and our column type is also date. Let's click on OK. Now this is now propagated. Let's do a quick sync, and let's see. All right, so now the job is succeeded, and as you can see, it has generated the date. And there are several formatting options as well. You can make use of any other date functions here, like add date or different format date, whatever pattern you want, you can change the date format here. So for now, I'll just leave it as is. Let's go to the next thing here. Now we have only two columns, which is only ID and first name, last name. So let me pull the user details table wherein we have more data points. I'll again use it as a DB input, and I'll maximize this job design. Okay, now As I said, we can use tMap for any expressions, filters, or joins, and various other functions. We have seen the example for the expression. Let's look at the join. Okay, so all we have to do is just do a right click, choose a row, and we'll take the main stream of the output and connect to the tMap. So as soon as you connect it, you see this lookup, right? What it means is all the records from users will be used as a source, which is like a driving table, and the user details is joined to tmap as a lookup. So with this tmap settings, let's get in. All right, as you can see, the first section is our users, and the second is our details. And also, you can do for easier understanding, you can actually rename this column to call it as users. Um, okay, so we'll have to keep a different name as we have already used users here. I'll just keep user and then I'll call this as details. Okay, so when you now get into tmap, you'll be able to see the users and the details. So these two tables are joined based on the ID column. So I'll just drag and drop here. As you can see, this is our join. And if you want, you have a way to actually do a settings here. And there are four, different sections. We'll talk about these properties in just a couple of minutes. For now, I will leave it as a left outer join. And what I will do on our target side, we have only name and just the name, first name, last name. So what I'll do is I'll pull in the other details to our target. All we have to do is just drag and drop to this. I want this record insert date to be my last column. So just click on that column again, and on the bottom window, you have a feature to actually bring down that particular column to the bottom. So this is how you add your columns from various sources and then drag it onto the target component. All right, now let's click on OK. Yes, I want to propagate all the changes. Let's go ahead and run this job and see what it does. Okay, so now see we have actually populated this complete details from. So these first three columns are from our users table, and the remaining details are from our details user details table. So we have printed email, gender, IP address, and other data points here. And as we moved this record insert date to the last, it is printed in the last. Okay, so now that we have good data points, let's use some custom column. We'll create some custom column called as some experience, let's say, and we will create like a pay range, and also we will filter and then add multiple outputs. Okay, so as a next step, let's look at the other join models. Before we get into this join, let me show you a couple of examples for the expressions, and we will make use of a if-else condition, and we will also look at the filter, and after that we will come back to the join because this is going to be really interesting, and it is widely used and it's very important. So let's look at the additional expressions and filters. I will create a custom column here. All we have to do is just click on the last column, and under this section you can click on plus sign. So this will create a new column. Let me make use of this age and try to compare and generate a column for experience. So for this calculation, what I would do is I will mark it as integer. You have several data types available here. Based on the need, you can choose one. And the next thing, what I will do, I'll make use of this age column. Just drag in here, and then I will say that minus 25, assuming an employee has joined at the age of 25th, and if the current age is 30, then the total experience would be 30 minus 25, which is 5. This is just a random sample example to show you how it works. All right, so age minus 25. So this is how you can write your custom expression and then call it as one column. And in then I'll create one more expression here because this expression I want to use it as a filter across multiple multiple output links. So let me create this, and I will call this as pay range. What I'll do here is pay range. I want to make use of the salary field and then compute whether it is high or not. Alright, so for that, what I will do is I'll just try to put some condition here. So I would say details if the experience of a person is less than, let's say, 10 years. Okay. I'm saying the age minus 25 if the experience is less than 10, and if the salary, again we'll have to drag and drop, the salary is greater than, let's say, I'll just give 40,000 for now. So this is my condition. So I'm having two conditions here. First condition is if the experience range is less than 10 years, and if my salary is greater than 40, if both the conditions satisfy, then so this is the way you write if else condition inside tmap. So this is your condition, this total is condition, and that is separated by a question mark. This is to call true. If this condition returns true, then this will be printed, else you will be printing something called as medium. So this is how you write if else condition in tmap. Let me repeat again, this is your condition, and you should always separate it out with a question mark. This is the true value, and this is the false value. So if this condition is true, then it will return high, else it will return medium. All right, I'll go ahead and click on OK, and let's pull this column as well at the end, and let me rename this to pay range. All right, so now we have added two additional fields in our tmap, and let's go ahead and run our job. All right, I'm executing my job. Okay, I'll maximize this. Okay, as you can see, all the details are printed, and let me scroll to the right. Okay, so if you see this experience, this is basically the age minus the 25, which is 14, right? So this is how it is computed. The experience is computed, and in the last column on the pay range, if my experience is 14, which is greater than 10, and the salary is again for less than 40,000. So the else condition is getting printed, which is medium. So let's look at the other example. So the experience range is 7, but the salary for this person is 91,000. So this is how you can make use of custom columns based on certain operation expressions. You can compute your custom columns, and also you can print it this way. All right, so let me use these additional columns to put the filter on tmap. I'll edit it, and we have this pay range already computed. All we have to do is, if you see on the right hand section, this is the output. So there are four sections here. One is the tMap setting. We'll come to this in just few minutes. And all we have to do is, this is the expression condition for this. Okay, all I have to do is, I'll bring in, and I wanted to print only the pay range whose pay range is higher than the normal. So for that, you will have to either bring the variables, or you can bring in the source column here, and the syntax to check whether it is equal to certain text. All you have to do is dot equals, and you can write something like this. Okay, so the variable or the actual column value equals to high. If my value of this pay range high, then only those records will be sent to the target. So let's check this filter. I made this change, save the job, and I'm running it. Okay, and also quick thing to notice here, I have 1000 records in source and 1000 in lookup. And if you see, the only 251 records are having um, pay range as high. So let's look at them. Okay, so this is how you apply filters, right? The experience is 7, and but the salary is higher than 40. So this is how you create custom columns and also apply filter. All right, so let's say now I want two outputs. The one output should have all the 1000 records, and in the other one, I want only the higher one. So how can you do that? So that is very easy in tMap. You can actually minimize this. This is the minimize window. This is the we have minimized this, and now I will create another output. So this is how you create another output. Um, Users high pay. I'll just call this as users high pay, and now I'll again bring in these columns, and here from the details I'll just print the email, and then I will pay the salary. Okay, and then I want to print the range. So what we are trying to do in this output link, we are capturing just the user basic details, email, salary, and then the pay range. Right, let's click on OK. And when you right click on the tMap, go to row, you'll be able to see the new output. Right, just click on that, and you can just click on the job design area. Let's use another tlog row here. And as you can see, the link itself is showing user high pay. Okay, so this is our first output, right? And this is our second output. All right, so in this case, let's go ahead and do a sync, save the job. Let's go to the run and clear run. Okay, all right, so now it is printing to output. All right, so okay, I think we made a small mistake. Um, I want the filter of this to be printed here, because in the first output I want everything, and in the high pay output I want only the high. So this is how you need to set the filter. All right, let's go ahead and run it. Also, see now all those high pay are now written into tlog row 8. Let's go and check. Okay, so this is our tlog row 8. And okay, so the way it is printing, it's not very easy to read. So for that, I will go to this tMap, sorry, this tlog row, and I'll print it as a table. I'll run the job again. Okay, so now we are now printing all those highs. So this is the first output, which is tlog row, which contains all the 1000 for all the records. And if I scroll down, okay, so this is our tlog row where we want to print only the high. So this is how you can make use of this filter condition, and then write into multiple targets. So as we have seen the multiple target, let's say you have another table called department or any table as such. So tmap can take multiple inputs and it can give multiple outputs as well. And you can even specify all the join conditions within tmap. And even if you have multiple input or output, you can still have um, conditions, expression, filters, and everything. You can have it. And let's say we'll see now the other settings. Other properties are catch, output, reject. So now we are saying high. We are filtering only for the high. So this is our accept, right? The reject would be all other values other than high is reject. So if you turn this property to true, what this will do is it will just capture an output which is a reject whose value is not high. Basically, all other values apart from high. So this is how you can capture output rejects. And if you are performing any inner joins, you can also capture the reject of an inner join, which means let's say you have 10 users and but you have like 12 users 88 users detail only. So in that case 8 will be matched, right? Those will be the inner join results, but the remaining two would be considered as reject. So in order to catch those rejected records, you can set this property to true and then capture those in a separate target, and then probably you can work on that data quality check or anything like that. You can redirect it to a error file or error table and then follow up on this in a correction. So that's the use of inner join. And schema type is basically the inbuilt. We are using inbuilt. These are not global. These are local to this particular job. So that's how it is. All right. So now we have looked at all the filters and other properties on our target. Um, so even when it comes to filters, you can have multiple filters as well with ampersand ampersand. This is for and, or if you can use pipes. Two pipes is for or condition. So this is all about filters and other properties. And on this join, this lookup side, you have these four properties. Basically, what it does is the lookup model load once. So it has got a few options here. Load once, reload at each row, reload at each row with cache. So basically, what happens is when you establish a join and run your job, what happens is all your lookup records will be loaded as a first step in the entire job, and then it will start sourcing your main input. So what happens is with this option, this is the default one. The lookup data is loaded only once when you start the execution, and it will not be reloaded again. Which means if you want to do like a static lookup against target, you should always do a load once. But if your requirement is to do a dynamic lookup, as and when you insert data into target, if you want to do a target dynamic lookup, then you should be choosing this reload at each row. So what happens is each and every row is read from the source. It'll rebuild the lookup cache. Sorry, it will rebuild that lookup and then perform the join operation and then load it to the target. The third option is reload at each row with cache option. Every time this lookup is read, it's going to put in the cache and perform all the join operation until the end, and your entire lookup operation is completed. So this is just the only once. This is reloading at each and every record. First one is static, dynamic with cache option. So these are the lookup model available in tMap. So now I'll just go back with load once. And the next one is the match model. So let's say you have a few repeating IDs, or let's say there are some duplicates. So in that case, so this match model gives us the option to check for all those duplicate entries. Then you should be going with all rows, or you can do a unique match. If you have like ID 12345 and in your tag details table, let's say it's repeated like 10 times, then the first option it'll compare and join with all the other records as well from your lookup table. If you choose unique match, it's going to do a unique match for those first five IDs. Right, so that's when unique match is used, and most likely we will be using unique about 90% of the time. So that's how tMap has given this default match model. And the next thing is first match. Let's say you have five IDs here, and your detail tables has all the duplicated entries. Let's say 1111, 2222, 3333. So in that case, when you define first match, what will happen is the lookup will happen as soon as it encounters the first match in the lookup table, and then the values for that particular match would be returned from this lookup table. And the last option is all matches. So all matches is used when you want to do complete no match against all the records available in the lookup table. All right, so most likely we'll be using unique because as soon as we find a match, either we mostly do a first match or a unique match. Okay, the next step is the join model. So join model is having the two options. Either you can do inner join or you do a left outer join. And there are no options to do a right outer or a full outer. Um, you can pretty much use left outer join twice and then achieve the same result as full outer join. Or if you want to do the right outer, you would reverse your tables, main table and the lookup table, then that performs your right outer. So this is how these are the two options available for the join model. And by default, you have this left outer so that all the records from your main table is written read first, and it picks up only the matching ones from the lookup table. And for the non-matching records, it will be returning null values. So that's all about these join models here. And the last option is store temp data. So this is where very helpful, very useful. This is one of the performance technique. You can actually, if your lookup table is really huge table in terms of tens of millions, then you don't want to load everything on your cache of your job server. Instead, you can choose this option to true so that the data from this lookup is also saved on the disk, and it will not cause any memory issues or memory crash or a heap issues. All right, so these are the different properties available in tMap, the join part. Um, All right, just a quick recap. This is our main table. This is the lookup table. You can rename this, and you can set the lookup model and other match model, join model based on your requirement. And this is how you can perform the join, and you can have your variables created for each and every expression that you want to reuse. And on the target side, this is how you can create multiple outputs. You can create it by clicking on plus, and if you don't want some output, you can just click on this delete. This will just delete. And if you want to rename any columns here, you do that under this section. Click here and then do this change. Or if you want to change the data type or length, you can change it here too, both on the source side and the target side. All right, so let's say if you want to copy certain columns here, you have an option to copy, and then also there is a paste. So these are main options available within the tMap. That's all. We will now look at options how to catch inner join reject. For that, I'll go ahead and deactivate current this job. I'll just move it aside. All right, so for this demo, inner join rejects, I will bring in the users and then the details as our input, and I'll quickly take the tMap. I'll be connecting the users as a main input, and I'll be making users details as my lookup. All right, so in this table, I have all the records matching exactly. In order to reproduce that, I will set this to read only 900 records. So what happens? My users table has 1000 records. Now user details will be returning 900 records, so that we can catch those remaining 100 records into our inner join rejects. Okay, I'll quickly join based on the ID. I'll create the output. I'll call it as main output, and I'll create another output called rejects. Okay, so I created two outputs. In the main output, let's capture everything as is. Okay, so this is our main output, and in the rejects output is basically we are saying all the matches found between the main table and then the lookup table. We will specify as inner join, and we'll catch all the inner join rejects into a separate table. If we have 1000 records here and 900 only is coming, and the remaining 100 would be coming into our rejects. Okay, so I have made the join based on the ID, and now I have defined the join model as inner join. And let's see, so when that happens, when the reject happens, I want to capture only the users, those 100 users, those are missing details. Okay, all right, so that's all on this. Click OK, and we'll now connect main output to the tlog row, and we will bring another tlog row to capture all the rejects. All right, so now I have two outputs, one for the main and the other one for reject. All right, I'll go ahead and save the job. Since this is our reject, we will have to set this property to true. So what happens? All those remaining 100 records, those are not matching, will be returned into this particular target. Get. Okay, all right. I am going to save this job. Let's go ahead and run it. Okay, as you can see, 1000 records are read. 900 were the lookups. 900 were there in the lookup, and the first 900 went into our the main output, right? Wherever we have matching user IDs in both the tables, all those 900 went in here, and then the remaining 100 records, those that are not matching, is returned to the target. So in this case, you can capture this as an error, return into a log file or error table, and then send it for the data quality corrections. So this is how you make use of inner join reject feature. So this is all for now. So in this video, we have covered creation of expression. We have created a couple of variables, as you can see in our previous example. We were able to create expressions, use it as a filter. We created custom columns. We played around with some of the functions, talent date functions and string functions, uppercase. And then we looked at having multiple outputs, catching the output rejects. We have seen all this in this session. Hope you like it. Thank you.